All right, on to 3.2. Quick note before jumping into this one. If you ever struggle through a lesson, I know the last lesson was a doozy. That was a tougher lesson there. Feel free to always go back and go through that lesson again. For example, if we were just go back through multiples again, so here's where multiples start. Just go through it, and yeah, I already went through and solved these problems. You might even remember the answer to them still, but still go through the problem and see if you can solve them again. Even though you might already know the answer, see if you can go through it yourself, and just go through the motions and try to go through these problems again and find the answer to these. And then go and check your work and make sure that you got the answers correctly and things like that, just to see the second time through if you really got it. Even though you've already kind of seen me work through it once and you already sort of have the answer, still working through it and thinking through it again is going to help you a lot. So I recommend doing that. If there's any of these lessons that you really struggle with, go and do them again. All right. So moving on to divisibility tests. So this one's going to be a little bit easier than the last lesson. You might have done divisibility tests before. I know if you did Beast Academy, then you would have done that in BA4 is when it was introduced. And I really like this. This isn't something that I learned when I was a kid, but it's really helpful. So this is new to you, then it's going to be obviously new. But if this is a refresher, then this lesson probably won't be too bad for you. So let's try problem 3.6. Go ahead and give this a shot on your own, and then we'll get into it. So note that 12, 12, 12 is equal to 120,000 plus 1,200 plus 12. How can we use that fact to tell that 12, 12, 12 is divisible by 3? All right, so is 120,000 divisible by 3? Well, it's divisible if there's no remainder. So if we divide this by 3, well, we would get 4. 4 times 3 is 12, and then a bunch of zeros. Yeah, I think that's the right number of zeros. Okay, so, and that's going to be 120,000. So that's going to be 0 remainder. So that one checks out. That's divisible by 3. How about this one? Is this one divisible by 3? Well, sure. That's going to be 400. And we already know this is divisible by 3. That's going to be 4. So check, check, check. All 3 of those are divisible by 3. So 12, 12, 12 must also be divisible by 3. Okay, so now how can we quickly tell that 3, 6, 3, 6, 7 is not divisible by 3? Well, we can do the same trick. If we want to write it all out, we could do that. Let's go ahead and just do that, even though I know you probably don't need to. Let's go ahead and do it anyways. So this is going to be the same thing as saying, say 300,000. Right, to get that many spots, yep, plus 60,000 plus 3,000 plus 600 plus 30 plus 7. All right, so 300,000, that's divisible by 3. 60,000, 6 is divisible by 3. That's going to be good. 3,000, that's divisible by 3. 600, that's divisible by 3. 30 is divisible by 3, but 7 is not divisible by 3. So that is not going to work. So we know that that is not divisible by 3. In fact, we know that this whole big number is going to have a remainder of 1, right? Because 3 would go into 7. So these would all have a 0 remainder. So that's 0 remainder, 0 remainder, 0 remainder, 0 remainder, 0 remainder. And this is going to have 3 goes into 7 2 times with 1 left over. So that's going to be a remainder of 1. Okay, how can we tell at a glance whether or not a number is a multiple of 10? You probably already know this. Even if you haven't done divisibility tests, you probably know this. How do you know something is a multiple of 10? Well, let's go over the multiples of 10. See if we can recognize a pattern. There's 10, there's 20, there's 30, oh, not 34. There's 40, there's 50, there's 90, there's 100, there's 110, there's 1,000, 1,050. What do all of these numbers have in common? You probably see it. Probably see right here, and right here, and right here. that all these numbers end in 0. You cannot have a multiple of 10 that does not end in 0. So there you go. It's a multiple of 10 if it ends in 0. All right, is every multiple of 10 also a multiple of 5? Well, again, the multiples of 10 are 10, 20, 30. So is 10 a multiple of 5? Sure. 5 times 2 is 10. Is 20 a multiple of 5? Yeah, 5 times 4 is 20. Is 30 a multiple of 5? Yep, 5 times 6 is 30. So yes, every multiple of 10 is also a multiple of 5. We also discussed that in the last section. Okay, how can we tell at a glance whether or not a number is a multiple of 5? Well, let's do the same thing we did in the last slide. So let's go over the multiples of 5. Multiples of 5 are 5, 10, 15, 20, 25, 30, 35. Let's jump to 95, 100. Let's get some 3-digit numbers in there. 105, 110. Okay, that's enough for a pattern, I think. If we wanted to do 995 and 1,000. So we have a 4-digit number in there, and 1,005. All right, so those are a bunch of multiples of 5. So do we recognize a pattern here? Well, they're not all the same, like we had for 10. They're not all zeros, and they're not all 5s, but it is a 5 or a 0. And it goes back and forth, right? 5, 0, 5, 0, 5, 0, 5. We skipped to 95 here, so 5, 0, 5, 0, and so on. So we know it's a multiple of 5 if it ends in a 5 or a 0. Okay, so those two are really easy. Knowing if it's a multiple of 5 or 10 is super easy. How can we tell at a glance whether or not a number is a multiple of 2? All right, well, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. All right, so this pattern here, we have 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. This looks like all the even numbers to me. So I don't see anything here that ends in a 1, 3, 5, 7, or 9. So if it's an even number, it's a multiple of 2. You probably already knew that. All right, so which of the following numbers are divisible by 4? Okay, so we don't have an easy, if you've done divisibility tests, you know the easy way to do this. But let's go ahead and do this the hard way. So 12, is that divisible by 4? Absolutely, we know that. 12 divided by 4 is 3. No remainder, easy. All right, how about 312? Do we think that is divisible by 4? Let's see. Okay, so 4 would go into 30 how many times? So if we do 7 times 4, that's 28. That seems pretty good. So let's try 70. That's 280. That leaves us with a 2 and a 3. 31 minus 28. Okay, so 32. And then that would give us, that'd be 8 more, right? Would be 32. And no remainder. So that one is also divisible by 4, so that's good. How about 512? Let's try that one out. So it's 4. Well, we got 100. We can do here. So 400. It's going to leave us with, well, this is going to be easy. Oh, no, because there's 100 there. 112. Thought it was just 12 for a second. Okay, so let's see. Lost my train of thought here. Okay, 4 would go into 11. Let's say 2 times, that would give us 8. So let's try, let's do 20. And that would be 80. So let's do 2. Let's do 3. And there we go. We got 32 again. So plus 8. And that would be 32 here. And so that checks out. That is also divisible by 4. 2512. All right, 4 goes into 25. 7, not 7, but 6 would be 24. Let's do 600. That would be 2400. That would leave us with 112. And look at that. We had 112 here. And we know we got that down to a 0 remainder, so we know that this is going to be good. Start recognizing some patterns here, taking some shortcuts. All right, so divide that by 4. We have 1,000. So we've got 4,000. We're left with 312. 312, that's right there. We already know that that is divisible by 4, so we know that that's going to be good also. All right, so all 5 of these are divisible by 4. Did I say 12? 4. All 5 of those are divisible by 4. Okay, is every multiple of 100 also a multiple of 4? How do we find that out? Well, let's see. Let's try 100 first. 4, that's going to go in 20 times to be 80. It's going to leave us with 20 there, which was plus 5. Yeah, that checks out. How about 200? Well, 20, this one's an easy one, right? That's going to be 50. That one checks out. How about 300? Divided by 4. That's going to go in 7 times. 28. Well, let's do 70. Leaves us with 20. And yep, that checks out too, because 4 times 5 is 20. So it's looking pretty good so far. Haven't completely proven this yet, but so far everything's looking good there. Maybe we'll do one more, see if we can recognize a pattern. So let's do 400. Well, we know that one's divisible by 4, obviously, because that's going to go in 100 times. How about 500? Do one more. All right, so that's going to be 100. Would leave us with 400 here and get us back down to 100. And now we've got a pattern because now we're back to 100, which we've already proven. So that, I think, is safe to say that every multiple of 100 is a multiple of 4. Okay, use your answer to part B to explain why all of this stuff is divisible by 4. Okay, interesting. So we know from B that every multiple of 100 is divisible by 4. So we know that 700 would be divisible by 4. And 700 minus 688, that would give us what? Let's see, 6, 10, 9, 10, be 2, 1. So that'd be 12, and we know 12 is a multiple of 4. Because basically this would be, 688 would be 12 less than 700, right? So if we do 700, which we know is a multiple of 4, because all multiples of 100 is, and we subtract 12, which we also know is a multiple of 4 because it's 12, we would get 688, which is this number right there, which we now know is divisible by 4. Okay, so now explain why this is not divisible by 4. All right, so we know 300 is going to be divisible by 4. So that means that 304 is divisible by 4, 308 is divisible by 4, but 310 is not divisible by 4. All right, hopefully all that made sense. I know it got a little bit messy there, but hopefully it made sense. All right, in this problem, we discover a method for determining whether or not a number is divisible by 9. All right, notice that 765 is equal to 7 times 100 plus 6 times 10 plus 5, okay? And then break this down more, and 100 is equal to 99 plus 1. 10 can be broken down to 9 plus 1. Okay, and then further break this down, we're just going to distribute here. So it becomes 7 times 99 plus 7. 7 times 1, but 7. Same thing here, distribute this. 6 times 9 plus 6, and then we have our plus 5. Okay, so far so good. I'm following. Then what do we do here? Okay, so we just moved this over here. We can use the commutative property to put all the addition together. So we have 7 times 99 plus 6 times 9 plus, and then all of our addition. Okay, good so far. So yeah, I noticed that. That's good. I'm fine with that. As shown above, 765 is equal to 7 times 99 plus 6 times 9 plus 7 plus 6 plus 5. Notice that 7 plus 6 plus 5 is divisible by 9. 7 plus 6 plus 5 would be 13 plus 5 would be 18. So yes, that would be divisible by 9. So explain why this tells us that 765 is divisible by 9. Okay, so I think at this point, now that you've gotten here, knowing that this is going to be 18, which is divisible by 9, then try to explain why all of this is divisible by 9. Okay, well, we know that 99 is divisible by 9, so that if we divide by 9, this is going to have a 0 remainder, right? It's going to be 9 times something would get us here, because 99 is just the same thing as saying 9 times 11. We can actually just rearrange this. We can do this. We can do 11 times 7. And so it would be 9 times 77. So if you were to divide by 9, you would be left with 77 with 0 remainder. So that checks out. That's divisible by 9. 6 times 9, if you divide by 9, of course, you just get 9 back. We already said that 18 is going to be divisible by 9. So because all those three are divisible by 9, then 765 is divisible by 9. So now, do you need to do all this work and break it down like this every time you do a 9's divisibility test? No, there's a shortcut, but this is showing you why this 9's shortcut will work, and we'll see that soon. Okay, notice that all this stuff equals 18. Explain why that tells us that. So these are the same numbers. See the 8514, 8514. Why that is divisible by 9. Okay, so just because 8 plus 5 plus 1 plus 4 is 18, why does that tell us that 8514 is also divisible by 9? Because if we look back up here, let me clear this board a little bit. If we look back up here, we can see that what we ended up doing with this 3-digit number was breaking it down into hundreds. We know it's 7 hundredths. We know it's 6 tens and 5 ones. And we broke that out to 7 times 100, 6 times 10, because again, 7 is in the hundreds position, 6 is in the tens position, and 5 is in the ones position. Broke that down, and then broke it down further by doing 99. We know it's 99 because, we do 99 because we know that is divisible by 9. And we do this to 9 plus 1 because we know 9 is divisible by 9. And then all we're left with is this digit here ends up getting multiplied here. So we have this digit, we have this digit, and we have our ones digit. So it would be 7 plus 6 plus 5, which we got right here, 7 plus 6 plus 5. And so as long as this is divisible by 9, we already know this is going to be divisible by 9. Everything leading up to it is going to be divisible by 9. And once we break it all down, all we're left with is these digits here, 7, 6, and 5. 7 plus 6 plus 5. Everything else we already know is going to be a multiple of 9. So if you add up all of the digits and that's divisible by 9, then you could say that the number is divisible by 9. Okay, so as long as 8 plus 5 plus 1 plus 4 is divisible by 9, which it is, then that would tell us that 8,514 is divisible by 9. If we wanted to go through and do all the work and break this up into thousands and hundreds and tens and ones, and then the thousands become 999 plus 1, the hundreds become 99 plus 1, the tens become 9 plus 1, and break it all out, it's really going to come down to, at the very end, you're going to be left with a bunch of stuff that's multiples of 9, and then 8 plus 5 plus 1 plus 4, just like we did here. All right, so determine whether or not 5, 9, 8, 1, 4 is divisible by 9 without dividing 9 into all that stuff. All right, so we just showed that if you add up all the digits and that is divisible by 9, then the number is divisible by 9. So let's see what we got here. We have 5 plus 9 is 14, plus 8 is what did I say, 14? So then 22, 23, and 27. I had those numbers in my head correctly. 27, and that would be divisible by 9. So this would check out to be divisible by 9. All right. Let me make sure I got that last addition correct before moving on. Don't want to lead you astray. Yep, 27. Okay, so it is divisible by 9. Okay, so next problem here. In the previous problem, we noted that the 765 became this, right? We broke it down, and we're left with a bunch of stuff that's multiple of 9s, and then the digits added up. Are both 99 and 9 divisible by 3? Well, we know that 9 is just 3 times 3, so 99, I guess it must be divisible by 3, right? 99, we can just do a quick division. And so that's going to be, let's see, 3 goes into 9 3 times. 3 times 3 is 9. Oh, that'd be 30, right? We already know what the answer is going to be here, but we'll just work it out anyways. And then 3 goes into 9 3 times, so it'd be 33. So yes, and no remainder. That's good. And is 9 divisible by 3? Of course it is. So yeah, both of those are divisible by 3. So if 99 is divisible by 3, and 9 is divisible by 3, and we said that this is 18, and 18 is divisible by 3, because 3 times 6 is 18. So 765 is also divisible by 3. Okay, so is 67242? Well, let's just add up the digits. Let's see, 6 and 2 is 8 plus 2 is 10. So that's 10, 17, and 21. Is that divisible by 3? 21 is indeed divisible by 3. Now, is that enough to say that it's divisible by 3 just by adding up the digits? What would happen if we were to split this up? So this would be 60,000, so it would be 6 times 10,000, which we can break up into 999 plus 1. 7 would be 7 times 1,000, which we could break up into 999 plus 1. And this would be 2 times 100, which would be 99 plus 1. 4 would turn into 4 times 10, which would be 9 plus 1. And so 999 is divisible by 3. 99 is divisible by 3. 9 is divisible by 3. All those are divisible by 3. And then all we're left with is the stuff at the end, and to see if that is divisible by 3. And in case it was, so this number is divisible by 3. All right, explain why this is not divisible by 3. All right, 6 and 4 is 10. 8 and 1 is 9. So that's going to be 19. And 19 is not divisible by 3. All right, so next one, 3.12. A is the units digit in the 4-digit number 463A. If 463A is divisible by 3 and by 4, then what are all the possible values of A? Okay, this one's a little bit trickier, but go ahead and pause this and see if you can figure this one out. Okay, so how do we know if something is divisible by, well, let's do 3 first. I think this one's a little bit easier. How do we know if it's divisible by 3? Well, all the digits have to add up to be a multiple of 3. So if we have 463A, so far we have 6 plus 4 is 10, plus 3 is 13. So we have 13 so far. 13 is not divisible by 3, but what will be the next thing to be divisible by 3? Well, 15 is divisible by 3. 15 is a multiple of 3. 18 is a multiple of 3. And to make 15, we'd have to add 2 to this. To make 18, we'd have to add 5 to this. What's the next multiple of 3? 21. To make 21, we'd have to add 8 to this. And Next one will be 24, but to make 24, we would have to add 11 to this, and we only have one digit here. So it has to be either 2, 5, or 8. So those are the possibilities for A. It's 2, 5, or 8. So it has to also be divisible by 4. Well, we know it can't be 5 because no odd number can be divisible by 4. So that rules that one out. So if it was, let's say it was 2, then this would be 632, right? So let's say it was 632. Do we know if 632 is divisible by 4? Well, we know 600 is divisible by 4 because all multiples of 100 are divisible by 4. So that means that 604 is divisible by 4, 608, 612 is divisible by 4. So if you keep going, I think 632 would certainly be divisible by 4 because 32 is divisible by 4. All right, so that was certainly an option. How about 8? So if it was 638, well, again, we know that 600 is divisible by 4, so 604 is divisible by 4, and so on. We know 632 is divisible by 8. 636 would be divisible by 8, but not 638. So that would not work, and that would not work. So A would have to be 2. Okay, 3.13. N is the tens digit in the 5-digit number, yada, yada, yada. If that is divisible by 9, then must that number also be divisible by 4? Okay, so first of all, we got to make this divisible by 9, right? So how do we know if it's divisible by 9? All the digits add up to a multiple of 9. So far we have, let's see, 8 and 2 is 10, 6 and 4 is 10. So far we have 20. And that's not a multiple of 9. The next multiple of 9 after that would be 27. So 27, we'd have to add 7 to this, so n would have to be 7, right? So if n is 7, then this number would be 2, 4, 6, 7, 8. And I think that's the only option, right? Because the next multiple of 9 would be 36. And to make 36 from 20, we'd have to add 16, but we only have one digit. So our only option is for n to equal 7. All right, so is this also divisible by 4? All right, so we know that 600 is divisible by 4. So starting from 600 to 604 to 608, it's going to be only these last two digits we really need to look at. And is 78 divisible by 4? I don't think so. I don't think that it is. So we want to check it real quick. If we're not totally sure, we can go ahead and do that. So 4 would go into 7 one time, or 10 times for 78, and that would give us 40. That's 38. We know 38 is not a multiple of 4. We can get to 32, we can get to 36, but not to 38. So that would not be divisible by 4. All right, and we have one final slide here before we close out this section. We've got 2 videos to go check out. And here is a breakdown of all of the divisibility tests. Again, if you came from Beast Academy, you probably already knew these, and this lesson was a good refresher for these. But if this is all new to you, this is really useful stuff here to be able to quickly know your multiples and your divisibility and things like that, which comes in handy a lot going into algebra. So going over these really quick, if it's divisible by 2, you know it's going to be an even number. Divisibility test for 3 is you sum all of the digits, add up all the digits, and if the sum is a multiple of 3, then it's divisible by 3. For 4, you can look at the last 2 digits and see if that's a multiple of 4. The reason why that works is because you know all multiples of 100 are divisible by 4, so you can start there. And then just look at the last 2 digits. So 5, we know that the last digit is going to be 0 or 5. 9 is the same as 3. Sum all the digits, and it has to be a multiple of 9. And 10, that's a nice easy one. The last digit has to be 0. So those are our divisibility tests. There's also some tests for like 25. I think that one's a pretty simple one to know. I think there might be a couple other divisibility tests that we might talk about later, but these ones here are really useful to know. So try to memorize these, and then I will see you in 3.3.